So we are solving a system using elimination or substitution. When I look at number 1, and I see that the x's are lined up, and the y's are lined up, and the equal signs are lined up, and the constants are lined up, I'm going to do elimination. But to review, to eliminate, you have to add the two equations together and get rid of the x's or the y's. What looks like it would be easier to get rid of? The x's. But to do that, I have to multiply the top equation by -2. So that we get -2x plus 8y equals -18. That way, when I add them together, the x's cancel out. You don't cancel out one of the variables, you can't solve. Then I'm going to add up my y's. I'm going to get 5y. I'm going to add up my constants and get -5. And we solve for y. Divide both sides by 5, and we get y equals -1. But this is not the answer. Because we're trying to find x and y that fit into both of those equations, that make both of those equations true. So we found y. How do we find x now? Plug it in to one of the original equations. I'm just going to choose the first one. So I'm going to have x minus 4 times y is -1 equals 9. So x plus 4 is 9. Take away 4, x equals 5. So we found what x equals. How do I know that I've made no mistakes? I plug both x and y into the other original equation that I haven't used yet. So I'm going to plug 2 times 5 minus 3 times -1, and it has to equal 13 if I've done it correctly. 10 plus 3? Have I done it correctly?
Whoa.
Yes. So my solution, my answer is the ordered pair, 5, -1. Notice how I have parentheses, because it is an ordered pair, not two separate x's, but it is an x and a y, so put it as parentheses, an ordered pair. Now what that means is if we're not going to take a lot of time to do this, but if I were to graph both of those equations on an XY chart, on an XY graph, one of them would look like this, kind of, and the other one would look like this, kind of. And this ordered pair, 5, -1, would be where the two graphs intersected. That's what we're finding, is where both of these graphs intersect, where they cross each other, at an ordered pair. Okay? So that was by elimination. We can also solve by substitution. And again, this is total review from Algebra 1, and we did this in Chapter 1 this year. So we're just reviewing. So substitution is where you make one equation equal to one variable. You see it says y equals, whatever y equals, I replace that, I substitute it in for y in the other equation. So we're putting one equation inside of the other one. What I will have is I'll have 3x plus, I still have that 5, but instead of y, I have 2x. Now I solve for x. So I have 3x plus 10x equals 0. So I have my x value. What do we do with the x value? Plug it into one of the originals. Y equals 2 times 0. So y is 0. All right, I have x and y. How do I know that I did it right? So we plug it back into 3 times 0 plus 5 times 0 should equal 0. And it checks, so I know that my solution is at 0, 0. What does that mean? That means if I graphed both lines, which I'm totally sketching right now, this kind of looks like them, but not perfect. If I graph both lines, one of them looks like this, and I think the other one kind of looks like this, maybe, kind of like that. They both cross at the origin, 0, 0. Okay? So we're doing that today, only today's lesson doesn't have 2 lines. Today's lesson has possibly 1 line and 1 not line. Or 2 not lines, right. And this is just an example of what you might see. You will know that it is linear if x and y are to the first power, so like no other exponents on x or y, then you'll know that it's a line and it's linear. So if there's other exponents, it's nonlinear. That one is quadratic or a parabola shape. And when we have a line and a parabola, this is all vocabulary, this is all just pictures, this is what to expect. You can have 3 situations. You could have no solution where they don't intersect. You could have 1 solution where they only touch 1 time. And in your 1 solution, you might want to add another example for 1 solution. They could cross like over here. It does not have to be at the vertex where they cross. That's another 1 solution. You could also have 2 solutions where they cross twice. There's multiple different answers that we could get here. We could also have 2 parabolas that don't cross. 2 parabolas that cross once, and 2 parabolas that cross twice. Okay, so that's all vocab. This is what we're trying to do, is find where they cross. We're going to do 3 examples. The first one, we're going to use the method of graphing. We did an entire chapter, chapter 2, we did an entire chapter on how to graph these kind of equations. Quadratic equations, parabolas. We did an entire chapter on that. We have a cheat sheet that I printed out for you that you also used on a test. Remember, I gave you all these formulas, like how to find the AOS, how to find the vertex, how to find the y-intercept. You remember they had a formula page? You can use that if you need it still. There are multiple ways of graphing this. I'm going to choose 1 method right now to do it. There are other ways. So you can use other ways. Got it? The method that I'm going to choose is I'm going to rewrite in vertex form. By using complete the square. And I'm choosing to do it this way because complete the square was something that we did recently. So it should be more fresh in our mind. So I'm choosing that method. But you could do it by finding the AOS using negative b over 2a. Remember that stuff. So if I'm going to rewrite this in vertex form using complete the square, what should we do first?
Oh, divide by.
What should we do?
Yeah.
Move the -1 over to the other side. Yep, that's what we want to do first. Thank you. So now I have y plus 1 space equals x squared minus 2x space. Because in that space, we're going to complete the square. Draw those squares in. How are you getting that number?
Divide by 2 squared.
We take the middle term, which is -2, divide that by 2, and square it. B divided by 2 squared gives us 1. So we have to add it to both sides.
Y plus
So I have y plus 2, and then on the other side, we're going to factor it. X, and then remember this sign, minus, and then we do b over 2, 1, squared. This is all review from the quiz we just took. That lots of you did really well.
two squared.
Now what should we do?
Square root.
Nope, we're not solving, we're just putting it into vertex
Oh.
form.
Subtract 2.
Right, we're going to subtract 2. So I have y equals parenthesis x minus 1 squared minus 2. That is vertex form. I'm just going to write vertex form right underneath it. This is x minus h squared plus k. So what is our vertex? 1, -2. That would be our vertex. So I can go ahead and graph 1, -2 on my graph. I'm going to go ahead and graph that. 1, -2. That's my vertex, so I know that my AOS is right there. To find other points, is there a stretch? The A value is 1, so there is not a stretch. So this is basically just the parent function moved. So remember when we did all those parent functions over and over and over again? From here, where do I go?
Up 1.
Up 1 and out 1? Both directions? If I went out 2, how much would I go up?
4.
4, because it's squared. If I went out 3, I would go up 9. So however you choose to graph it, that's your choice. This is the method that I chose, but you could certainly do a different one. All right, that's only half of what we had to do, though. We have to find where they cross by graphing. So we still have this equation to graph. I'm going to put the work up here.
Well, that's an easy equation because it's a line.
It is linear, and we know linear is y equals mx plus b. And we always begin with our b value. What is the b value? -1, and that is the y-intercept, which is 0, -1. So you graph it, and what do you notice as you're coloring in that dot?
It's on another dot.
It's intersecting with the first graph. I've already found one of my answers.
Is there 2 answers?
I don't know yet. Let's
No, okay, no.
find our slope. What's our slope?
-2.
-2, and remember slope is rise over run, so we put that over 1. From that point, we go down 2, and then we go right 1. We go down 2, right 1, down 2, right 1, or up 2, left, up 2, left, up 2, left. So the question is, how many times does it cross and where?
1. half.
I can't cross a half a time. But you could certainly draw your graph not very accurate and think that it crosses more or less than it does. You've got to be really careful with your graphs. This one only crosses once. What did we find? 0, -1.
Vertex and the solution, just the solution.
Just the solution. The vertex was to help graph it, and then the solution is what we're trying to find. Okay, so when you do your assignment and it says to solve it by graphing, just be careful with your graphs. Just draw them accurate so you can tell where they cross. And then I've given you the online assignment today so that you can check your answers as you go. So I can type that in and it'll tell me if I'm right or wrong.
If there's just one answer, wouldn't there just be one blank to fill in the answer?
I looked at what it looked like and now I don't remember. I think what it is I think they might have a bunch of answers and you have to click the ones for one. I think that's how it works. Hopefully we'll get time to look at it.
Yeah.
Okay. Example number 2, we're going to solve by substitution. So example 1 is your example of how to solve by graphing. Example 2, we're solving by substitution. So to do substitution, you have to solve one equation for y equals. You have to solve one of the equations for y equals, and then substitute y equals in the other equation. So if you look at the top and the bottom one, which one's easier to solve for y equals? Say it. Yes. For what we need to do, for what is coming in the future, yes. It will be y equals. Okay, so I think that bottom one's going to be easier to make y equals. Just take away x from both sides, and done. Y equals 4 minus x. That would be the second equation. And we're using substitution, so we're going to take what y equals and replace y in the other equation. You have to be very careful because there's always silly things like a negative sign stuck in there. So when I replace it, this is what it looks like. X squared plus x minus parenthesis 4 minus x. Why don't I do what? I'm going to. You're ahead. I'm going. Okay, so then I do not want the parentheses there, so I am going to distribute that minus sign into the parentheses. So we've got x squared plus x minus 4 plus x equals -1. You will notice I know that I've done it right so far because I only have x's. Put your phone away, Caleb. I only have x's. If I had y's and x's, then I can't solve for the one variable. But I only have x's. Even though I have an x squared, I only have x's. So what I'm going to do now is solve for x. So here comes the stuff we've been doing the past couple weeks. To solve for x when there's an x squared, what do we need to do? Combine like terms, we also need something over here. We need to make a 0, we need to set it equal to 0. So we're going to add 1 to both sides so that it equals 0. And I'm going to combine my like terms. Here's a like term and a like term on the same side. Once you have that, you have all these options. You've got complete the square. You have factoring.
Square root.
You have, well, square roots doesn't always work. You have square roots, but it's not going to work for this one.
Yeah, but you basically try it.
Right. It's not going to work if you just have an x.
Yeah.
Just so you know, I would not always just go by square roots. You can also do quadratic formula with the song. You've got all these options.
Whoa.
This one always works. Complete the square always works, but sometimes yucky. So if you're not sure, I would always go by quadratic formula. But I know how to factor, and when I look at this factors quickly. If it doesn't factor, go with quadratic formula. But this one does factor fast. Guess and check. What makes -3? 3 and 1. Positive 3 minus 1. That equals negative or positive 2x in the middle. If you don't like factoring, you don't have to do factoring. You can do quadratic formula. But I like factoring when it's fast. So then x plus 3 equals 0. X minus 1 equals 0. We get -3, positive 1. But that's not the answer. What are we trying to do? We have a,
Intersect.
what do we have? We have a linear and a nonlinear. This is total rough sketch. I don't know where these are actually graphed, but we have a linear and a nonlinear. We are trying to find where they cross. And what kind of answers will I be given? Will I be giving? There's 2 of them, but they're ordered pairs. So when I have x equals, I don't have the answers yet. What do I need to do with x?
Plug it into equations.
So that second equation that was x plus y equals 4,
Yep.
I'm going to plug in x one at a time into this equation. So I've got -3 plus y equals 4. Add 3, y is 7. That ordered pair is -3, 7. Then I'm going to plug in 1 plus y equals 4. So y has to be 3. So that ordered pair is 1, 3. We have 2 places where these graphs cross. I have 2 ordered pairs. Okay? And here is the actual screenshot of what the calculator, but we're not doing the graphing calculator today. It's going to take you a lot longer to do graphing calculator stuff. I'll teach you that next class. I will teach you how to do it on there, how to find where they cross. But you can see the parabola and the line cross in 2 places, and if you look carefully, one's at -3, 7, the other's at 1, 3. All right, last example. This example we are doing by elimination. You want to eliminate the y. To do elimination, eliminate the y. In order to do elimination, we have to have the x's and the y's and the x squareds and the equal signs and the constants. Everything has to be lined up. Are they all lined up?
Yes.
Will the y's cancel?
Yes.
Oh, yay. So we don't have to multiply by anything. These will just cancel. So I'm going to add them up and get 3x squared minus 3x equals -2. Then what should we do? Yes.
Should we take a 3x out of the side, or is that?
Nope, not yet. Because what do we want to do on the right
Oh,
side?
I guess it's.
Add 2. ways of solving. We just solved for x. You could do complete the square, quadratic formula, factoring, square roots. What always works? Quadratic formula.
Equals opposite.
Oh, Jared's gonna sing it for us. Ready? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Thank you. Thank you. Now, hold your pause. So we're going to do that. We're going to do x equals opposite b, so opposite of negative 3, plus or minus square root b squared is 9, minus parenthesis 4 times 3 times 2, whew, all over 2 times 3. So we add together 9 minus 24, and we get negative 15. Now what do we do?
Oh,
Take the negative out and make it I, radical 15 over 6.
oh, basic practice. Right.
What are we trying to find?
Oh. So we approximate.
What's I mean?
Imaginary systems. Oh.
I means the answers are imaginary. That means there isn't a real solution. So I do not need to plug these back in to find the y value because there isn't one.
Well, then why is there a y?
There's two equations, and I'll show you here. There's two equations, but when I graph them, they don't cross. So there is a y for each of them, but when I graph them, they don't intersect. So what we were trying to do is find where they intersect. If you get an imaginary answer, that means they don't intersect. Okay? So imaginary means no intersection, no answer. If you get imaginary, that means no real solution. Yeah.
Could we have just done the discriminants? You know, that would just.
Well, yeah.
Yeah.
I mean, by the time you do that,
You would have
Yeah.
already done it quicker.
yeah, I just always do the whole thing. But yeah, definitely. Okay. I'm going to get you started on those student practices. I'm going to get you started of what method I would use. And I'm doing this because it's being recorded. You can totally work ahead of what I'm doing. But you have to do this on your own for your assignment. So again, I'm modeling what I would do. There is more than one way of doing each of these. I'm modeling what I would do. Oops, there's one thing. So on every single one of these, we have to get rid of y. Before we can solve it, we have to get rid of y. So I thought, look at the first one. We could do that by elimination, or we could do it by substitution. I'm going to do substitution because it already says y equals. You can do elimination, but you'd have to multiply by -1 to do elimination. I'm going to do substitution. Since that's what y equals, I'm going to replace it with y. I'm going to have negative x squared plus 4 equals negative 4x plus 8. And then I'm going to make it equal to 0 by adding x squared and subtracting 4. That would be my first step. And then we're going to solve for x. And I would do this one by factoring because it factors really easy. And get what x equals. But remember, that's not the answer. Once you get what x equals, you have to find y also. So just plug it back into one of the originals. Oops. I'll just plug it in the first equation, y equals negative parenthesis 2 squared plus 4. So I get y equals 0. So my answer is 2, 0. Okay, the second one, again, I have to get rid of y. I personally prefer elimination over substitution, with the exception of number 1. I prefer elimination. So how could I eliminate y? Can I just add them and get rid of the y's? No, what would I need to do to this second equation? Multiply by negative 1. So I'm going to rewrite both equations so that I can line up the stuff that is like. What happens if you forget to multiply by negative on like the 5? Everything's going to be wrong, isn't it? We have to be very careful and take our time. So we're going to add these up, and I'm going to get x squared plus x, the y's cancel, equals negative 5. After we have that, then we need to make it equal 0. So add 5. Make it equal 0. Once we have it equal to 0, then we have to solve for x. I'm not going to solve that one for x. Does it factor quickly? No. So quadratic formula, yeah. We'll do, oops. Opposite b is negative 1 plus or minus square root 1 squared minus 4 times 1 times 5 all over 2 times 1. Okay.
No real solution.
So when you do the discriminant, you get negative 19. So we know there's no real solution. That would have an imaginary answer, so there's no real solution. I know there's a lot of stuff, but almost all of it we've done in some form. There's really not that much new stuff. It's just all the stuff combined. Last question. Would you do elimination or substitution? I would do elimination. Why? Because if I look at the y's, are already going to cancel. You have to be very careful, though. You have to line up the stuff that goes together. So on top, 2x squared plus 4x minus y equals negative 2. But on the bottom, x squared, nothing, and then plus y equals positive 2. Like there's nothing there, so leave a big space. 3x squared plus 4x equals 0. And how are we going to solve it? So once you have it equal to 0, then we solve for x. You could do factoring, you could do quadratic formula. Square, I want to do that. I'm going to do this one by factoring. You could do quadratic formula if you want. I'm going to do this one by factoring because there's a greatest common factor. So I'm going to take out x, and I'm left with 3x plus 4. So x is 0, and 3x plus 4 equals 0. And we take away 4, and divide by 3. And we get 2 x's. 2 x's. but we have to find the two y's that go with those two x's. So which equation should I plug them back into? Second one, yeah, x squared plus y equals 2. So I'll plug in the first one, x equals 0, 0 plus y equals 2, so y is 2. I'm sorry, my pen is not working very well today. So one of my answers is 0, 2. Then my second answer, I'm going to plug in negative 4/3. That's going to be an amazing, beautiful number, won't it? Then I got to square it, plus y equals 2. When I square that, I get 16/9 plus y equals 2. You can use your calculator. I'm doing this by hand. Yeah. Make some room for it, though. I'm going over here. Make some room for it. In order to subtract 16/9 from both sides, that has to be 9.
So 18
Mm-hmm. So if I take 18/9 minus 16/9, I get 2/9. So my second answer would be negative 4/3, 2/9. That would be my two answers. Incredibly beautiful representation of fractions in real life, right? Woo! Grab a computer. Log on. You will need scratch paper. You will need scratch paper.
But I won't.
You will need scratch
I
paper.
do it in my head.
Mm-hmm.
Or I'll just get all the answers around here.